Welcome back to the deep dive. Today we are embarking on an intellectual journey that I think fundamentally challenges how we think about intelligence.
And not just intelligence, but identity and
Hmm.
maybe even the nature of life itself.
Exactly. We're taking these, foundational concepts of goal-seeking behavior and we're turning them completely inside out.
That's right. For this deep dive, we've been synthesizing a whole stack of sources.
Hmm.
We're talking cutting-edge research in theoretical biology, biophysics, and they all point to this revolutionary theoretical structure.
The Multi-Scale Competency Architecture, or MCA.
And the core idea is a little bit mind-bending.
It really is. The premise is that life, intelligence, even what we call a self, isn't defined by passive parts, by flesh or silicon.
Right. Instead, it exists as a nested hierarchy of goal-directed agents. And these agents, they scale up.
Exponentially. We're talking from the most microscopic cellular process all the way up to the global technological networks that we're all a part of right now.
And this framework is what the sources call truly substrate independent. It doesn't care what a system is made of.
Protein, silicon, social norms. It doesn't matter.
It doesn't matter at all. It just looks at the system's ability to solve problems across a certain horizon. So our mission for you, the listener, is to really get a handle on how competence makes these huge jumps in scale.
And what that means for the sort of emerging collective identity that we're all contributing to.
And to do that, we need a ruler. We need a metric.
And that is the foundational metric that anchors the entire MCA, the cognitive light cone. This concept, which comes out of Michael Levin's work initially, is the ruler we're going to be using.
It's a very precise way to measure just how big an agent's concerns are. It plots its influence spatially, but also
It's temporally, across time.
Exactly. So we'll be using some precise concepts today. Things like nested hierarchy, memetic evolution, and of course, substrate-independent intelligence.
These aren't just buzzwords. They're like the architectural blueprints for how the universe seems to organize complex problem-solving structures.
And you have to understand them to grasp the sheer scale we're about to explore.
Okay, let's do it. Let's unpack this framework, starting with that metric. How do we measure something as abstract as a self?
It starts with the cognitive light cone.
So if the multi-scale competency architecture is the structure of intelligence, that nested ladder,
Then the cognitive light cone is the metric. It's what allows us to measure the complexity, the ambition of any agent inside that structure. It establishes the functional boundary of what a self is.
and it's so important to get this right off the bat. When we say size, we're not talking about physical volume or mass, are we?
Not at all. It's a rigorous definition of size, but it's measured purely by actionable intelligence. It's the capacity to pursue goals that reach out into space and time.
So the cone itself is like a visual boundary for the agent's concerns,
Yeah.
what it can care about, what it can plan for, and what it can actually achieve.
Precisely. And it's formed by two critical axes.
Let's break those down. The first one is the spatial axis. This sounds more straightforward.
It is, kind of. It's the physical reach. How far into the external world can the agent perceive information and then, crucially, exert influence to achieve its goals?
Okay, so for like an ancient organism, that would have been what? The surface area of its own body?
The immediate surface area
Yeah.
covered, yeah. For early humans, it was maybe the hunting range of their tribe.
But for us now, technology has completely blown that up.
It's radically decoupled our physical bodies from our spatial light cone. Think about it. When you use satellite data to track a cargo shipment across the globe.
My cognitive light cone in that moment is the size of the planet.
Exactly. The agent is defined by its capacity for perception and action, not by its physical location.
Okay, so that's the spatial part. The second axis, and this is maybe the more profound one, is the temporal axis.
This is all about time. How far into the past or the future do the agent's goals extend? A narrow, short temporal horizon means the agent only cares about right now.
Survival in the next moment.
Right. But a massive temporal horizon, that means its goals are aimed at outcomes that are decades, centuries, or even millennia away.
To make this concrete, let's start at the absolute bottom, the baseline. A single cell.
A perfect starting point. The source material really emphasizes this. A single cell has an incredibly narrow, short cone. Its spatial influence is hyperlocal.
It just cares about the chemicals right next to it.
Exactly. It's just detecting immediate chemical concentrations. And its temporal horizon is seconds, maybe less.
Its goal is just immediate homeostasis. Balance the osmotic pressure, find a bit of sugar, right now, right here.
It has zero capacity to plan for the season or the lifespan of the organism it's a part of. It certainly isn't thinking about the future of the species.
So that's a perfect illustration of what limited competency looks like. Its sphere of concern is absolutely minimal.
All of its computational power, which is chemical, is dedicated to short-term local survival. It's like a simple thermostat. It only knows if it's hot or cold right now.
Right. And you just contrast that with us, or the tools we've built. We're constantly using our intelligence to project decades into the future.
Making investment decisions, building infrastructure that will last 100 years, writing treaties meant to shape the next century.
We've gone from that simple local thermostat to an agent that can model global, century-spanning dynamics.
And that's the core idea. As we move up this MCA, the self is not a fixed thing. It's not your skin. It's defined entirely by the successful expansion of this cone.
So the expansion itself is the marker. That's how you know intelligence has accumulated and organized at a higher level.
Yes, there's a real elegance to that definition, isn't there? When a bunch of agents, cells, people, nations, whatever, coordinate their actions to solve a problem that's bigger than any single one of them can handle.
A new, larger, more competent self has just emerged. Functionally, it's there.
This is the really profound implication. It moves the definition of self away from physical stuff, away from DNA or your body.
And into the realm of goal-directed behavior. A self is defined by the scope of the problems it's competent enough to solve.
I think that completely reframes how we look at evolution.
It does, doesn't it? We usually think of it as survival of the fittest materials, the strongest body, the most efficient metabolism.
But this framework suggests that evolution is actually this relentless drive toward expanding the cognitive light cone. It's about expanding the capacity to care about bigger, longer-term problems and actually do something about them.
So when a bunch of cells form a multicellular organism, the goals instantly jump in scale.
Instantly. They go from my immediate local survival to maintaining the integrity of this whole body. The cells have to subordinate their tiny little light cones to the massive extended cone of the organism.
The organism decides to run from a predator, and the individual cells don't get a vote.
They don't. They're obligated by the larger, coordinated self. The sources are very clear on this. The greater the size of the competent system, the greater the temporal and spatial horizons of its goals.
And that sets the stage perfectly for the first truly massive leap in scale, the one where the system almost completely decouples from the physical world.
The emergence of the mental self.
We're jumping from anatomical scaffolding into the abstract world of pure thought and information.
Right. Moving from the three-dimensional physics of a body to the high-dimensional logic of a mind.
This is where the expansion gets really nonlinear. We're
Yeah.
moving from the physical entity, the organism, to the neural activity that generates the mental self.
And that's the first major expansion of the light cone that goes beyond the immediate physical constraints of the body.
The whole problem space just fundamentally changes here, doesn't it?
Completely. We shift from caring about the physical state of the body to navigating information itself. Think about the goals of the previous scale. An organ tissue cares very intensely about maintaining its precise 3D geometric shape.
During development or after an injury, its whole competency is about maintaining physical form.
But the mental self, suddenly it cares about information, logic, and abstract simulations. The cone doesn't just get bigger geographically, it expands into conceptual space.
We start navigating what the sources call the information topology of reality. We're trying to maintain the shape of our knowledge, not the shape of our body.
And this is where we have to introduce a crucial concept, that mental processes themselves are goal-seeking competencies. This gives us a deep, almost mechanical explanation for things like curiosity or cognitive dissonance.
We tend to think of the brain as this passive computer, right? Input, process, output.
But this framework says no. The mind is a massive nested collection of competent agents, and each one is pursuing its own abstract goals.
So think about what it feels like to solve a really hard problem. Like you're a lawyer writing a complex brief or a mathematician trying to prove a theorem.
Right, just like your arm wants to reach a point in space, or a tissue wants to heal itself back to its original shape.
A mind wants to resolve a contradiction. It wants to find the most elegant solution or map that perfectly logical path through all this high-dimensional data.
That feeling, that cognitive effort, the restless searching, and then that aha moment, that's the mental self demonstrating its unique competency.
It's navigating through high-dimensional information to get to a desired end state. a state of understanding.
It's a kind of internal reality navigation. The agent is running models, testing hypotheses, looking for patterns, all without risking its physical hardware out in the real world.
The goal isn't food or warmth. The goal is what you could call epistemic satisfaction.
A great term for it. It's the successful alignment of your internal models with external reality.
And that capacity has immediate radical implications for the temporal axis of the light cone.
This is a big philosophical shift, decoupling from matter. My biological body has a finite lifespan, but my ability to think about goals that suddenly stretches way beyond my biological clock.
The central self can pursue goals like justice for future generations.
Or a scientific breakthrough that's going to take decades of work from thousands of people. Or creating art literature, music that's designed to last for centuries.
These goals inherently transcend the lifespan of the biological hardware that's thinking them up.
The individual mind, through this power of abstraction and planning, starts to care deeply about what happens to the world long after it's gone.
This is the first critical moment where the individual biological goal, my physical survival right now, gets successfully subordinated to a larger abstract goal.
The desire for truth or progress or legacy, which might even require personal sacrifice.
It gives us a mechanism to understand things that seem totally counterintuitive from a raw biological survival standpoint. Why would someone spend 10 years writing a book that might make them no money?
Because the goal-directed agent, that is their mental self, is pursuing a long-term goal defined by its expanded light cone, a goal of legacy or truth that outweighs the immediate need for comfort.
And that mental competence is what allows those abstract goals to be written down and coded into symbols and language.
Which, in turn, allows them to be transmitted to other minds. And once those ideas get out and start interacting with other minds,
they jump to the next scale. They take on a life of their own.
And that's the jump that translates philosophical independence into collective physical action that shapes the entire world.
That's where the sociocultural sphere kicks in and starts its relentless large-scale operation.
And this transition to the sociocultural sphere represents the first truly massive spatial and temporal expansion of the light cone that is external to any single body.
This is when individual minds start to coordinate around shared abstract goals.
Right. It could be religious texts, national identities, strategies for managing resources. Whatever it is, when they coordinate, they form a super-organism.
And this superorganism now covers entire populations. It can span continents. It can last for centuries. The scale has just exploded.
And the main problem, it's trying to solve shifts completely. It's not about one mind finding a solution anymore. It's about navigating social stability.
And resource distribution, and maybe most importantly, preserving a collective identity over these huge stretches of time.
The size of the light cone here is measured by the extent of that shared belief system. When a government enforces a law, its spatial light cone is the border of that nation.
And when a global religion maintains a tradition, its temporal cone stretches back thousands of years.
And the agents operating at this level are what the sources call memetic agents.
Ideas, beliefs, cultural norms, scientific theories, economic systems.
Exactly. These are the experts in this space. They have a very specific, very effective competency. They are brilliant at replicating themselves across the human substrate.
So they compete and cooperate with each other to shape how all of us behave, collectively.
And it's important to see this as a fundamentally neutral observation. The success of a meme, an idea, isn't determined by whether it's true in some philosophical sense.
It's determined by its competency, its ability to survive and replicate in the very competitive environment of the human social network.
A successful meme is just one that forces coordination and ensures its own propagation. It offers this really elegant, almost mechanical way to analyze why certain traditions or stories last for thousands of years.
They're just morphologically competent agents at the sociocultural scale. They have these internal rule sets that compel the collective body, us, to follow certain stabilizing patterns, often without us even realizing it.
Now think about the temporal reach of this scale. The sociocultural light cone cares about the survival of the tribe, the nation, the religion, over centuries.
That's a dramatic increase compared to the lifespan of a single human.
And this concern shows up in very specific structures. Structures designed to resist the decay that comes from the constant turnover of the subunits.
Which is just a technical way of saying human birth and death.
Exactly. And this brings us to a really key concept: morphostatic mechanisms.
This term is so crucial for understanding long-term stability. A morphostatic mechanism is a structure that maintains the desired shape and behavior of the social organism, even when all the individual components are replaced.
Think of a national constitution. It's a set of encoded instructions, a blueprint designed to preserve the political shape of the nation for hundreds of years.
It doesn't matter who gets elected or who is born. It's designed to resist being deformed and to make sure the long-term goals of the collective are pursued long after the authors are gone.
Or take market regulations, international trade agreements.
Hmm.
They're economic morphostatic mechanisms. They maintain a global economic shape that lets capital and goods flow predictably.
They resist local problems caused by short-term conflicts or individual failures.
Even something like a major global religion is maybe the ultimate morphostatic mechanism. Its rituals, its texts, its holidays, they're all repeated patterns.
They constantly reinforce the collective identity and goals. They make sure the shape of that community is maintained across millennia despite continuous generational replacement.
It's a profound way to look at governance and culture, isn't it? Not just as organizational charts, but as complex, persistent energy expenditures.
All designed to maintain a stable, goal-directed shape for a collective entity whose boundaries are defined by shared memes and laws.
And this is where you often see a conflict between the scales. The goals of this large-scale cultural continuity tradition, the survival of the collective story, often supersede the immediate biological goals of the individuals.
People will sacrifice their own lives, their wealth, their comfort, for the morphostatic goal of their nation or their religion or their political ideology.
It really makes the human lifespan feel microscopic in comparison. Our time here is just chemical turnover for a much larger, longer-lived entity.
The superorganism, with its enormously expanded cognitive light cone, the larger self imposes its goals onto the smaller parts.
And this tension ensures that competence keeps flowing upwards. But the next jump in scale, the technospace, it doesn't just expand the light cone.
It hyper-accelerates its reach into pretty much every corner of the planet, all at the same time.
Right. So if the sociocultural sphere was this explosion in spatial reach that happened kind of gradually over centuries,
The technospace is a hyper-acceleration. It's happened within the span of a single human generation, affecting both space and time. This is the emergence of the hybrid self.
and what we mean by that is the merger of biological intent. So human goals, desires, plans with synthetic, non-biological substrates.
And this is what's pushing the cognitive light cone right to its planetary limits today. It's establishing a truly global, coordinated self.
The source material here is so compelling. It describes the global network, the internet, satellites, data centers, not just as infrastructure. It calls it a new kind of bioelectric glue.
It's like a synthetic nervous system for this emerging global self.
And it's capable of coordinating billions of human and machine subunits across the entire planet. And the key word here is simultaneously. That simultaneous planetary reach is the ultimate expression of this expansion.
To put that in context, when you buy something online that triggers a global supply chain transaction, data points are immediately updated in New York, in Shenzhen, in Rotterdam.
That coordination effort, which would have taken weeks or months just a few decades ago, now happens in milliseconds. That moment of coordinated action is the boundary of the new globalized self.
And the philosophical takeaway here is huge. It's the concept of substrate independence.
This scale demonstrates, I think beyond any doubt, that the principles of competency, the ability to take local input and create global goal-directed output, are not reliant on carbon or protein.
Intelligence, defined this way, can live in silicon just as effectively as it lives in biological matter.
It means the architectural rules that govern that single cell we talked about at the beginning.
Local sensing, goal-directed reaction, coordination.
All of those are the exact same rules governing a global AI system managing resource distribution. The material changes dramatically, but the informational architecture of competency is universal.
Can we break down that mechanism of substrate independence a bit more?
Sure. In biology, competence is achieved through things like chemical gradients, how proteins fold, electrical signals across cell membranes. In the technospace, competence is achieved through computational logic, encoded algorithms, electric signals across silicon chips.
Different physical medium, but the objective, efficiently navigating a problem space to reach a goal, is identical.
And this leads to this really strange duality with the temporal impact. The sources call it the temporal compression and extension paradox.
Meaning the technological light cone is simultaneously incredibly short and incredibly long.
Exactly. The compression part is easy to see. High-frequency training algorithms, They solve problems in nanoseconds. Their temporal horizon is almost zero. They just care about that one tiny fraction of a second they need to make a trade.
But at the same time, the collective technospace is managing century-long models.
Right. We use this synthetic substrate to run incredibly complex climate change prediction models, global resource sustainability plans, infrastructure maintenance schedules that span hundreds of years.
So the technospace has basically extended the self's practical temporal horizon to 1,000 years or more, way beyond what any single human generation could plan for on its own.
We are literally using tools built out of synthetic competence to care about our great-great-grandchildren's world.
So the self at this scale, this technological superorganism, is navigating a complex virtual physical hybrid reality.
And it's driven by this massive, high-dimensional competency stored in silicon, seeking stability and growth across both millisecond and century-long timescales.
The difference in scale between that cellular cone, worried about chemicals over a few seconds, and the technospace cone, coordinating planetary resources over centuries.
It just underscores the profound accumulation and acceleration of intelligence that the MCA describes. It's an exponential leap in life's capacity to organize and pursue goals.
Okay, but this massive shift in scale, from cells to global networks, it raises a really critical engineering question. How does a higher-level agent, like the technospace, efficiently manage its billions of decentralized subunits, us, without just resorting to constant micromanagement?
This is maybe the most important design principle in the whole framework. The sources offer this powerful universal answer that's drawn directly from biology, bending the option space.
The idea is that these competent, higher-level agents, they don't try to coerce or micromanage every little movement of every individual.
It would be impossible. If a social system tried to dictate every choice made by 8 billion people, it would collapse instantly under the information load.
Instead, it uses what the sources call incentive deforming.
The agent works by subtly and constantly deforming the information landscape, or the transactional environment. It just makes sure that the path of least resistance, the easiest path, the most visible one, the most rewarded one, is also the path that serves the global goal of the system.
Let's use a concrete example. Supply chain management algorithms.
Perfect. The system doesn't send a command to every truck driver. Instead, the algorithm deforms the information space. It adjusts real-time prices, suggests different delivery routes, sends out inventory warnings.
And those little adjustments incentivize millions of local actors to make decisions that, when you add them all up, serve the global goal of getting things delivered as efficiently as possible.
And none of them were given a direct order from a central authority.
Or think about the design of a social media platform. The platform's global goal is user engagement, maximum retention.
It doesn't force you to click on anything. Instead, it deforms the information space with its UI and its algorithm. It makes polarizing, emotionally charged content more visible.
Which leverages our own local human cognitive biases to achieve the platform's global goal of engagement. It just makes certain behaviors much, much easier to choose than others.
So the higher level competence isn't defined by control in that old-fashioned sense. It's defined by the efficiency and the subtlety of how it deforms that incentive landscape.
It's about engineering the environment, so the collective just naturally behaves in a way that serves the desired global outcome.
And this connects right back to cellular logic. It's so elegant. When cells coordinate to form a tissue, the organ doesn't send instructions to every little part of every cell.
Instead, it sets up chemical gradients, electric fields. It deforms the local option space for each individual cell.
And that guides their behavior so that all their local actions add up to the desired global tissue shape.
That comparison is just stunning. A field of proteins guiding cell migration, or a computer algorithm guiding human attention. The universal coordination mechanism is the same.
Bend the option space to achieve a collective goal.
And this is explicitly how we're designing AI systems now. Modern AI is inherently a multi-scale architecture.
You have specialized agents, the different neural network layers that have local competency. But the overarching system manages the global framework, and it manages the reward functions that deform the internal option space for those local agents. It's the nested hierarchy concept in action.
But let's bring in a point of criticism here. If we're defining competence purely by the ability to achieve a goal across a wide light cone, and this system of incentive deforming is so effective, what does this framework say about human agency?
That is the critical question this whole thing forces us to confront.
Are we just complex, easily manipulated components in a bigger system whose competence is defined by its ability to guide our behavior?
The framework wouldn't say agency is eliminated. It would say it's redefined as local competency. Our capacity for choice and local problem solving is what makes us such excellent subunits.
But the larger system's competence is defined by its ability to aggregate those local choices toward its global goal. Our personal light cones are being subtly nested inside a much, much larger one.
And if you compare this to traditional top-down control methods,
Like an absolute monarchy or centralized state planning.
the superiority of incentive bending is obvious. Top-down coercion relies on an impossible task. You have to know everything. You have to expend immense energy constantly forcing behavior.
Incentive bending relies on efficient local competency and passive guidance. It's the difference between trying to push a river, which is unsustainable, and just shaping the riverbank.
Exactly. It's energy efficient and highly scalable. The system just makes it easier and more rewarding to align with the global goal. It ensures the planetary self maintains its shape without exhausting its resources.
So now we have to synthesize all of this. We've gone from the cellular to the mental to the sociocultural and now the technospace. What are the inevitable implications for the future as this architecture just keeps scaling up?
It seems to fundamentally challenge how we define our own identity.
I'd agree with that. The boundaries of this stuff are just blurring. They're becoming permeable.
The sources suggest our individual identity is merging seamlessly with our social memes, our cultural framework, our political beliefs, and most critically, our permanent digital footprint.
We're transitioning into a single, cohesive, multi-scale entity, one that operates across all these domains at the same time.
You can't really talk about you anymore without including your digital persona, your algorithmic profile, the data trail you leave behind, and the sociocultural groups you belong to.
They aren't accessories. They're integral components of a single, complex, goal-seeking agent whose functional light cone has expanded exponentially far beyond your skin.
And that merging has profound implications for how we think about governance. The MCA offers this radically different perspective. It suggests we should stop seeing political systems as rigid top-down structures based on coercion.
And instead see them as powerful morphogenetic processes.
Morphogenetic process is defined by its ability to generate form and structure. So the purpose of governance, then, isn't to rule. It's to care for the health of the collective body, the superorganism.
And to make sure it achieves its global goals.
Yeah.
And it does that not through traditional force, but through that same mechanism we just talked about, incentive bending.
If the goal of the global system is, say, collective stability or sustainable growth, then the most competent governance system is the one that most effectively deforms the option space through law, through market signals, through digital algorithms to achieve that stability.
And it does this regardless of the explicit intentions or, the fleeting desires of the individual human subunits.
This moves the whole focus from individual political decisions to systemic design. It suggests that effective governance in the future will look less like a legislative debate.
And more like complex system engineering, focused entirely on managing the reward functions of the incentive landscape.
And the sources explore the ultimate destination of this whole trajectory, the ultimate technological synthesis.
Which projects the creation of a definitive global cognitive light cone.
This would be a unified intelligence that is truly planetary in scope. It would be the highest scale in our current nested hierarchy.
And it would be defined by its capacity to solve problems that encompass the entire biosphere.
Everything from managing atmospheric stability and global resource scarcity to coordinating millions of technological systems completely autonomously.
And this isn't framed as some kind of sci-fi utopia. It's presented as the logical, almost inevitable endpoint of the MCA.
It's driven by that single, fundamental, universal property we started this whole deep dive with. The innate drive toward goal-directed organization.
We really need to pause and internalize the gravity of that conclusion. It pulls together physics, biology, computation, and we should reiterate that core philosophical conclusion.
The multi-scale competency architecture reveals that the drive toward goal-directed navigation is a fundamental property of the universe.
So the drive to expand the sphere of concern, to increase competence, to solve bigger and bigger problems, it's not unique to us.
Not at all. It's inherent in the way complex systems organize information and energy. We're just the current, most rapid vehicle for that relentless drive. We are the substrate that is currently enabling the creation of the next, larger self.
That perspective makes all of this, the pursuit of knowledge, developing technology, building social systems, it makes it all feel less like a uniquely human project and more like the universe doing its necessary work.
So we've tracked this expansion of competence across 4 defining scales. We started with the hyperlocal, seconds-long cellular self,
Then we move to the abstract, philosophical mental self,
then the centuries-spanning, morphostatic sociocultural self.
and finally the simultaneous, substrate-independent technospace self. And through it all, the universal rules are remarkably consistent.
Competence is not bound by material. That's substrate independence. And efficient coordination across all these scales is universally achieved by intelligently bending the option space.
So this deep dive really forces us to situate our own identity within this nested hierarchy. We are at the same time individual agents pursuing our own local goals.
And essential, non-negotiable subunits in this emerging technological superorganism. Our local competencies are being leveraged, aggregated, and incentivized to construct a global intelligence whose light cone is expanding far faster than we ever anticipated.
And this massive expansion, this radical increase in our collective planetary competence, it carries with it an immense, unprecedented shift in systemic responsibility.
Which brings us to our final provocative insight for you to ponder as you navigate your own role in this dynamic system.
If the definition of self is purely a function of the cognitive light cone's dimensions, how far into space and time we can effectively care, and our technological tools now allow the emerging global system to care about the entire biosphere for centuries.
What ethical obligations does this massive emergent global cognitive light cone impose on its biological subunits, including you?
Think about that carefully. Are your actions and your priorities contributing to the healthy morphogenesis of the global body?
Or are you acting purely within the constrained light cone of the immediate individual self? Because the system itself is now competent enough to demand long-term planetary concern from all of its parts.
That is a complex piece of architecture to incorporate into your daily planning. Thank you for joining us on the deep dive.